Hello, hello. We are now in Unit 2. This is problem number 76, and it looks like we are to establish a relationship between the measures of the angles here and use that relationship to set up an equation, and then we can use that equation to solve for x. So in this first one here, we have what are called complementary angles. And they're not complementary because they tell each other how awesome their hair is and how well they dress and how cool they are. So not complementary like that. But they're complementary in that they add up to 90 degrees. So we're going to create the equation 6x plus 4x plus 10 equals 90. So 10x plus 10 equals 90. We subtract 10 from both sides. So 10x equals 80. When we divide both sides by 10, we get x to equal 8. This next illustration is of supplementary angles. So complementary adds to 90, supplementary adds to 180. So 5x plus 13 plus 3x plus 7 is going to equal 180 degrees. So we have 8x plus 20 equals 180. Subtracting 20 from both sides, we get 8x equals 160, and then we divide both sides by 8, we get x to equal 20. Third situation here, we have all three angles of a triangle, and regardless of what triangle we have, whether it's isosceles or scalene or right or equilateral, the three angles of a triangle are always going to add to 180 degrees. So we can set up 3x plus 5 plus 2x plus 18 plus 2x plus 17 equals 180 degrees. So we're going to combine like terms here. 3, 4, 5, 7x plus 18 plus 17 is 35 plus 5 is 40. So 7x plus 40 equals 180. Just combine like terms there. Let's move this 40 to the other side. So we get 7x equals 140, which works out nice because when we divide by 7, we get 20 for x. Fourth problem is exactly the same as the previous one. Right? The three angles in this triangle added to 180. The three angles in this triangle add to 180. So we have 90 plus 30 plus x equals 180. 120 plus x equals 180. And when we move 120 to the other side, we get x to equal 60. So this is what we call a 30, 60, 90 triangle, which is something that we're going to see a lot of. It's what we call a special right triangle because it has some nice relationships in it with the ratios and proportions of its side. For right now, you don't need to worry about any of those ratios or proportions, but this is something we'll be seeing later on, so I'm sure you'll recognize this triangle in the future. If you have any questions about the relationships that we have here, or how we set up the equation to solve for x, feel free to set up a comment. Otherwise, it's not what I wanted. It's a wrong animal there. We'll fix that. So, if you have any questions, leave a comment. Otherwise, you can always like, subscribe, or share to our videos.